Hi everybody and welcome back to my channel. My name is Sepi and I'm the owner of Helix Academy in Toronto. So if you're trying to find or contact me, you can email me at info@helixacademy.ca. Today we're solving a function of f of x equal 5x over x squared minus 1, and we're trying to sketch a graph. Now in order to do that, we need to find the xy intercept. We need to find and use the first and second derivative test in order to be able to find out and figure out how this function looks. So the first things first, I'm going to find out what the x-intercept is by putting the whole function equal to 0. So if f of x is equal to 0, and then find the y-intercept by putting the x equal to 0, so f of 0 is equal to what? So if I put the whole function equal to 0, so the numerator should equal to 0, therefore x needs to be 0. So if x is equal to 0, I have 5 times 0 over whatever it is. It doesn't matter because I will get a 0. So from this point I have a 0, 0 point, and from this point I also have a 0, 0 point. So they overlap, and I know that I have an intercept at my origin. Okay, now the next thing to find here is to find my vertical asymptotes and my horizontal asymptotes. For my vertical asymptote, I have to put the denominator to equal to 0. So x squared minus 1 equal to 0. Then x squared is equal to 1. Therefore x is just plus minus 1. So I have two vertical asymptotes, one at x equals 1, and then I have another one at x equals minus 1. And for my horizontal asymptote, I look at the degree of the top and the bottom. If the degree of the denominator is higher than my numerator, then my horizontal asymptote is at y equals to 0. And that is the rule for horizontal asymptote. If you don't know this, you could actually Google it, and it gives you the 3 different possibilities of when d is smaller than n and when d is equal to n. How to find that and how it gives you an oblique asymptote. But for now, we're okay with this question. We know where our asymptotes are. All we need to figure out is what's happening between these numbers here and after this asymptote and before this asymptote on the negative side. Alright, so we need to do the first derivative test and put it equal to 0. So I need f prime x and put it equal to 0. In order to find that, let's rewrite f of x. There are 2 things I can do here. I can use the quotient rule, or I can bring x squared minus 1 to the top and give it a negative power, and then just do the product rule, which that's what I'm going to do here. Now, the product rule says, let's use a different color, if I have 2 functions of x that are multiplied together, my derivative is going to be the derivative of the first guy times the second guy plus the derivative of the second guy times the first guy. Okay, so I'm just going to apply that to my function here. So my derivative is going to be equal to derivative of x. Derivative of the first guy is 5 times the second guy plus derivative of the second guy, so the power goes, this is the power rule, and then I deduct 1 from the power, and then I take the derivative of what's inside, which is just 2x, and then times the first function, which is 5x. Okay, great. Now we're going to just rewrite this as a positive. And then here I will have minus 1 times 2x times 5x, so that's 10x squared over x squared minus 1 to the power of 2. So I basically just rewrote this whole thing. Now what I want to do is to take this a little bit further and see if I can take a common denominator here. That would be x squared minus 1 to the power of 2. This is missing a factor, so I'll have 5 times x squared minus 1 minus 10x squared. And then I can actually expand this and write 5x squared minus 5 minus 10x squared over this whole thing. So I'm just going to cancel these two out and write negative 5x squared minus 5 over x squared minus 1 to the power of 2. And then I can actually take out a negative 5 and write it as x squared plus 1 over x squared minus 1 to the power of 2. So this is basically my first derivative. What I'll do is that I put this first derivative equal to 0, as I mentioned, as I promised that I would over here. So I'm going to put this equal to 0, so the numerator should equal to 0. And since x squared is going to be equal to negative 1, x does not exist because I can't have the square root of negative 1, right? So I can't have, so there's no maximum or minimum for this function. Now the next thing I'm going to do is to take the second derivative of this guy. So what I'll do is that I write my first derivative here, and I'm just going to rewrite it. So I have a negative 5 x squared plus 1, and I'm going to bring the numerator up again. So I have a product rule, and I write it like this, and I try to take the derivative of this one now. So let's do a green color. In order to do that, I'm just going to keep the negative 5 outside. I could do this for the first part, but I didn't. I'm just gonna do it on this one for the sake of simplicity. And then this is my function 1, so this is my h of x. Now this is my g of x, for example. So the derivative of the first guy is going to be 2x times the second guy, and then we do plus the derivative of the second guy, and this is the chain rule right here, times the first guy. Okay, so this is all done. Now what we need to do is to pretty much simplify again and rewrite everything. So I have negative 5, and right over here I have 2x over x squared minus 1 to the power of 2, and then I have a negative sign here. And oh, sorry, I forgot to put deduct the negative. So over here I did the negative here, and then I had to deduct 1 from here, which I didn't, so negative 3. So I can bring that into the bottom, and then on top I have 2 times 2x, which is 4x times x squared plus 1. I can actually expand that, so it would be 4x cubed plus 4x, and then I can also rewrite this again. So I have negative 5. I can do a common denominator, missing 1 factor, so 2x times x squared minus 1, and then because the minus is basically multiplied in everything, I have minus 4x cubed minus 4x. Okay, so again over here I have 2x cubed minus 2x minus 4x cubed minus 4x. So I'm just going to simplify these. I have minus 2x cubed And then from these two, I have minus 6x. I think this is correct. It looks right. And then in the bottom, I have x squared minus 1 to the power of 3. Okay, looks good. These two look like they have a negative 2x in common, so I'm going to take that out. So minus 5 times negative 2x, it would be a positive 10x. And taking a negative 2x out of here, dividing this by negative 2x, I get just x squared. Divide this by negative 2x, I get just 3 positive over everything I had from the beginning. Okay, so this is my second derivative. Now what I need to do is to put this equal to 0 in order to find my concavities. Now, when I do that, I get the numerator equal to 0, so I have 10x equal to 0, so x is 0. And I also have x squared equal to well, let's write it, x squared plus 3 equal to 0. So I have x squared equals negative 3. So I know that x squared equals minus 3, so x can't be square root of negative 3 because we also don't get square root of a negative number. Therefore, the only critical point that we have is located at x equal to 0. So what we need to do is to go back and just pretty much we could do a sign chart here if you are asked to do that, and do 0 and try to figure out what's happening between 0 and your asymptote, which was at +1 and -1, and beyond 1 and -1. So we just give these numbers a bunch of random test numbers. So let's give it a 2 here and a half here and a -1/2 here and a -2 here, just to kind of test out and see what the concavity of my function is going to look like. So if I give it a, let's say, 2 here, I will have 10 times 2, which is 20, times 2 to the 2 plus 4, it will be a positive number. And in the bottom, I'll still have 2 to the 2, 4, it will be a positive number. So it's just going to be a positive second derivative. So my concavity is up. If I give it a 0.5, which is 1 over 2, I will have a 5 times 0.5 to the 2 plus 3 is a positive number, 0.5 to the 2 minus 5 minus 1 is a negative number, to the 3 is still a negative number. So I'll get a negative number in general, so I'll have a downward concavity. Similarly, if I give it a -1/2, I will get the negative number on top and a negative number in the bottom as well, because you get a -1/2 minus 1 is a negative to the 3, so it will be a positive, so it will be concave up. If I give it a -2, I'll also get a negative number. If you have any problem with these, post a question downstairs and I will get back to you, but these are the concavities here. So what I can do, so I know the concavity changes at 0 from up to down. So I already know that I have like a cubic function kind of form there. Going back, okay, I'm already back. So let's try to graph this. So it says the concavity is down here, between here to here, so I'm concave down. And then between here to here, I am concave up, so it must be, and I can't hit those lines, so I must be looking like this. And then over here, I'm concaved up between these two, so it must look like something like this. And I'm not hitting these lines. Why am I not here? How do I know if I'm not here? You could always do a test kind of point as well. So I can always give my function a 3. My function is right here. So if I do f of 3, do I get a positive number or a negative number? So I get a positive number on top, and I actually get a positive number in the bottom. So I know I'm in this quadrant. And then if I give it a negative number, I actually get a negative number, so I know that I am in this quadrant. So this is basically the graph of my function. I hope that you guys and this is useful to you. Make sure you subscribe to my channel. I'm gonna link it right here, so make sure you hit subscribe button. And if you have any comments, or make sure you like the video. Again, my name is Seppi and I'm from Toronto Helix Academy. If you guys are looking for tutoring, you can always message me in here and I'll be happy to help you. During the COVID situation, I'm doing most of my tutoring online. And yeah, let me know if you have any questions, and thank you so much for watching. Take care. Bye bye.